What's up, Walmart walkers? It's Miss Sorensen, video 23, counting principle. We've actually already done one of these problems before, but you didn't know it. We did a problem like this when we did the seating arrangement problem. We were really counting the number of possible ways to do something, and we did so by multiplying. We're going to see a little bit more about that now and kind of highlight when we would do problems like the counting principle. So take a look at this one. It says you flip a coin 4 times. How many different results can you have? Well, we can take a look at this tree diagram. Right? Obviously, you flip a coin and you either get, say, heads or you get tails. Okay, and then you get heads or you get tails. Then you get heads or you get tails, right? Then you get heads or then you get tails. And so here are all the possible outcomes that you could have in this situation. You could have heads, 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 tails. And notice that the blue represents the tails and the red represents the heads. So counting these, you could take a second to do that if you want, or you could just trust me that there's 16 of these. But do you really want to do this every time I ask you a question like this? The answer is no, of course you don't want to do that. So what's a different way we can do this? Well, I want you to think about having slots, just kind of like we did with the chair problem. And you say, how many possible choices do I have for each slot? Because I'm flipping a coin 4 times. That's why I have 4 slots. Well, for the first slot, I could have 2 options, heads or tails. For the next slot, I could have 2 options, heads or tails. The next slot, 2 options, heads or tails. 2 options, heads or tails. Just like the seat arrangement problem, we're going to multiply these. And we get 2 times 2 times 2 times 2, which does give us 16 results. 16 results, which is the same thing that you get for your tree diagram. So for the counting principle, don't overthink this. Think about the number of slots you have and how many possibilities for each slot. All right, you have 7 songs on your summer fun playlist. How many ways could you arrange this playlist, or could you play this playlist? Well, how many slots do we have? We have 7. So 7 slots. And how many songs could you play for the first slot? Well, you could play 7 songs. But if you've chosen a song for the first slot, then you only have 6 songs left. Then you have 5 songs left. Then you've got 4. Then you've got 3. Then you've got 2. And then you've got 1. And what are we going to do? We're going to multiply all these values. And when I multiply across, I get 5040. So there's 5,040 ways to arrange this playlist. Now, if you want, you can actually do 7 factorial. 7 factorial is the same thing as saying 7 times 6 times 5 times 4 times 3 times 2 times 1. And if you're not sure how to do that on your calculator, you basically just press math, and then you scroll over to probability, and then you press the factorial button, which I think is the 4th one down. And I also have a video for how to do that as well. All right. So remember, the counting principle is simply involves outcomes with different categories. It's very similar to a tree diagram, but it saves you a lot of time to do this. All right, you're making a new password for your computer. You're going to use 2 letters first and then 1 number, and you can repeat letters. So if I need 2 letters and then 1 number, I've got 3 slots. That might help you to say this is going to be a letter, and then a number. Well, how many letters are there in the alphabet? There's 26, so we've got 26 options here. And this does say that repeat letters are allowed, so let's say I chose an S for this, I can choose an S again, so that means I've still got 26 options. And how many numbers do I have? Well, you've got 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. That's a total of 10 options right there. So we're going to have 10. And of course, we're going to multiply all 3 of these. and that's going to give me a total of 6760 outcomes. There we are. All right, so that's the counting principle, basically determining the number of slots and then filling in each slot with how many possibilities there are. All right, example 4. You are creating a password with 4 digits. You cannot repeat a number. How many possible arrangements are there? Okay, well, we've got 4 digits, 1, 2, 3, 4 slots, and you cannot repeat a number. So I've got 10 numbers for the first. These are all numbers, and remember, no repeats. So let's say I chose the number 5. I can't choose 5 anymore, so really I'm down to just 9 options. Then I choose another number that I can't use for the next one, so I've got 8 and 7. There's not really a rule when you subtract and when you don't subtract, but in general, if you cannot repeat something, you're going to drop down a number each time. If you can repeat a letter or a number, they're not going to drop down. So just multiplying those across, and I get 5040, and that's going to be number of arrangements. Now I want to make a quick important note here that this is not equal to 10 factorial. Right, in order to have 10 factorial, that would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So you actually couldn't use that method in your calculator for this one. All right, let's move on to the next example. These are pretty self-explanatory, but it's good to do practice. Someone is guessing your phone number. They know it starts with 509. What's the probability they guess the rest of your number correctly? Well, a phone number goes like this, 509, and then you've got 3 digits, right? And then 4 digits. Well, you've got 10 options for this number, and the 509 is just what the number is. It's not part of our problem, so I am going to erase that, don't want to confuse you. So we've got 10 options for the first number, 10 options for the second, 10, 10, 10, 10. Now you can certainly do 10 times 10 times 10 times 10 in your calculator, or just realize this is 10 to the 7th, which is equal to 10 million. Of course, we've got 7 zeros there. And it's actually asking what's the probability that you guess the rest of their number correctly. Well, that would be 1 out of 10 million. So I wouldn't bet your life savings that you're going to guess someone's number correctly, even if you do know their area code. Okay, example 6 here. In Washington, the first 3 symbols on a license plate are letters, and the last 4 symbols are numbers. Find how many possible license plates there are in Washington. I'm not super sure if this is true, but it is true for my license plate. Not sure if it's true for yours. But yeah, let's go ahead and calculate this, given that we'd assume that this is true. So we've got 1, 2, 3 being letters, so L for letters. And then we've got 4 digits, 1, 2, 3, 4. Those are going to be numbers. And they certainly can repeat. That's totally fine. All right, so we've got 26 letters, 26 letters, 26 letters, 10 numbers, 10 numbers, 10 numbers, 10 numbers. And we're just going to go ahead and multiply all those across. And that'd be 175. Oopsie. It's 175,760,000 possibilities. All right, thanks for watching the counting principle video. Just remember to draw your slots. Try to figure out if things are being repeated or you have to remove letters. All right, thanks for watching, everyone.